Well, Algebra 2, this is our video key for section 8.2, and the exercises we had simplifying rational expressions by factoring. So in this particular exercise, we're going to be factoring by using the greatest common factor, or we're going to be using the method we use when our leading coefficient of a trinomial is 1. We've been calling those diamond problems. Or we're factoring when our leading coefficient is not 1, when it's greater than 1, and that's when we've been using the AC method. So let's get started on these 10 problems by looking at number 1. Number 1, we're asked to simplify the rational expression 3x plus 27 over 30x. We really don't have a trinomial in either case, so we're not going to be using the diamond problem. We're not going to be using the AC method, but let's see if we can reduce this by a greatest common factor. Is there a common factor that we can pull out of our numerator? Yes, we can pull out a 3. If we're looking at 6x plus 27, we can pull out a 3. So I divide 3 out of 6, I get 2x, and 27 divided by 3 is 9. Okay, how about on the bottom? Well, there's really nothing to do there. It's 30x. Good. So is there any simplifying I can do now? Let's look at our numerator and denominator. Can we reduce this fraction to 3/30ths? Sure. We can pull a 3 out of there and it cancels out. If we divide 30 by 3, we get 10. So our final answer would be 2x plus 9 over 10x. Number 2, we're given the rational expression r plus 1 over 7r squared plus 7r. Again, we don't have trinomials, so we know we're not going to use either of those methods, but can we pull out a greatest common factor and maybe reduce? Anything we can pull out of the numerator? No, that's pretty much as simple as it gets at r plus 1. How about on the bottom? Is there greatest common factor in our denominator here? Well, if we look at our coefficients 7 and 7, greatest common factor there would be 7. R squared and r, greatest common factor of our variables there, we pull out the smallest one, which would be r. So when I pull a 7r out of 7r squared, that leaves me with an r. And of course, 7r divided by 7r is just 1. So now I get r plus 1 over r plus 1. If I parentheses that, I got a nice little group that I can cancel out there. So my answer becomes 1 over 7r. Number 3, we have the rational expression x minus 1 over 10x minus 10. Again, we don't have a quadratic or trinomial to factor, so let's look for a greatest common factor here. Numerator is as simplified as it can get, x minus 1. Is our greatest common factor we can pull out of our denominator? Sure is, 10. We pull that 10 out, we're left with x minus 1. So just we can cancel out x minus 1 out of the top and the bottom, and we're left with 1 over 10 for our answer to number 3. Number 4, we're given the rational expression n plus 8 over 5n plus 40, and asked to simplify that. Let's take a look at our numerator. Is there a greatest common factor we can pull out of there? There is not. So we'll leave the numerator as is. How about the denominator? Is there a greatest common factor we can pull out of there? And there is, and it is the number 5. And we factor that 5 out, we are left with n plus 8. So we can see our numerator and the n plus 8 factor in our denominator will cancel out. And we are left with 1.5, or not 1.5, 1 over 5 is our answer to number 4. Okay, number 5, we're given trinomials in our numerator and denominator. We've got the rational expression a squared plus 6a minus 40 over a squared minus 9a plus 20. Both of our trinomials have a leading coefficient of 1, so it leads me to believe we can use that diamond problem method we had. We're looking for two numbers and we multiply together. In the numerator's case, we get to negative 40. And we add them together, we'd get to positive 6. Hopefully you've had enough practice at this point to where we don't have to draw the diamond out, but if we were to factor that numerator, what are two numbers that we multiply to get to negative 40, then when we add together get to 6? Let's not forget our a's. I think I'm looking at positive 10 and negative 4. Okay, 10 times negative 4 is negative 40. 10 plus negative 4 is in fact 6. So our top is factored. Now let's look at our bottom. We're going to have A's in front here of our factored form. So what numbers am I looking for that I can add to get negative 9? And when I multiply, I get to positive 20. I think we're looking at negative 5 and negative 4. So here's our factored form of our numerator trinomial and our denominator trinomial. Looking at this, we can cancel out this term a minus 4. So our answer will be a plus 10 over a minus 5 for number 5. Number 6, again, we have trinomials in the numerator and denominator, both with a leading coefficient of 1. So we're going to be factoring both of these using that method where we multiply two numbers together to get to our constant, and we add them together to get to the coefficient of our middle term. So looking at our numerator, if we were to multiply two numbers together to get negative 63, that add together to get to negative 2, I believe we'll be looking at negative 9 and positive 7. Negative 9 times 7 is negative 63, and when you add negative 9 and positive 7, you do get negative 2. So that's the factored form of our numerator. Let's look at our denominator here. I have x squared plus 14x plus 49. Looking for two numbers I can multiply together to get 49. When I add together, get 14. I think we're looking at 7 times 7. 7 times 7 is 49. 7 plus 7 is 14. So this is the factored form of our denominator. Looks like we can cancel out the factor of x plus 7 out of the numerator and once out of the denominator, giving us our final answer of x minus 9 over x plus 7. Number 7, I have a trinomial x squared plus 4x minus 12 over x squared minus 10x plus 16. I'm going to try to factor both of these trinomials, see if I can cancel anything out. So there are two numbers I can multiply together up here in the numerator that'll give me negative 12. And when added together, give me a positive 4. I believe we'll have like x plus 6, x minus 2. If I multiply 6 and negative 2, I do get negative 12. If I add 6 and negative 2, I do get a positive 4. So this is the factored form of our numerator. Let's take a look at our denominator, see if we can factor that. I'm looking for two numbers I can multiply together to get positive 16. And when I add together, I get negative 10. I believe that would be x minus 8, x minus 2. So negative 8 times negative 2 does equal positive 16. When I add negative 8 and negative 2, I do get a negative 10. So looking at this, I can cancel out the factor x minus 2 out of both the numerator and the denominator, and I'm left with the simplified rational expression x plus 6, x minus 8 as our answer to number 7. Number 8, I'm given the trinomial x squared plus 3n plus 2 over the trinomial x squared plus 6n plus 5. I'm going to try to factor both these trinomials, see if I can't cancel anything out. Let's look at the numerator. Are there two numbers I can come up with I can multiply together to equal 2, then when I add together equal 3? Positive 2 and positive 1. If I multiply 2 and 1, I get 2. When I add 2 and 1, I do get 3. Can I factor the bottom, the denominator here? The two numbers I can multiply together get 5. Yeah. And when I add together, get 6. So factored form of my numerator is n plus 2 times n plus 1. Factored form of my denominator, n plus 5 times n plus 1. I can cancel a factor n plus 1 out of both my numerator and denominator, and I'm left with n plus 2 over n plus 5 as my answer to number 8. Number 9, I have the trinomial v squared minus 4v plus 4 over the trinomial v squared plus 5v minus 14. I'm going to try to factor both the numerator and denominator, see if I can't cancel anything out. Factoring my numerator, are there two numbers I can multiply together to get 4? And when I add together, I get negative 4. That would be, I believe, a negative 2. Negative 2 times negative 2 is a positive 4. Negative 2 plus negative 2 is a negative 4. How about on the bottom? Can I factor that? I don't know why I'm writing ends. V. The two numbers I can multiply together to get negative 14, and when I add together, get a positive 5. Looks like that would be 7 and negative 2. Positive 7 times negative 2 is negative 14. When I add positive 7 and negative 2, I do get a positive 5. So this is my factored versions of both the numerator and denominator. I can cancel the factor v minus 2 out of both. I'm left with v minus 2 over v plus 7 is my answer to number 9. Okay, number 10, this is our final problem for this homework assignment. We're given the trinomial n squared plus 12n plus 35 over the trinomial n squared minus 3n minus 40. I'm going to see if I can't factor both of those and maybe cancel some stuff out. So let's look at the numerator first. Are there two numbers I can multiply together to get to 35, and when I add together, I get to 12? I do believe 7 and 5 gets us there. If I multiply 7 and 5, I do get 35. When I add them together, I do get 12. So that's the factored version of our numerator. How about our denominator? Are there two numbers I can multiply together to get to negative 40? Then when I add together, I get to negative 3. I do believe negative 8 and positive 5 will do it. Negative 8 times positive 5 is negative 40. And when I add negative 8 and positive 5, I do get negative 3. So that's the factored version of my denominator. I can cancel the factor of n plus 5 out of both the numerator and denominator. And that gives me my final answer of n plus 7 over n minus 8. So hopefully this video key helped you going through these 10 problems on this exercise. And if you were stuck, hopefully this got you unstuck. If you're still having some issues with some of the problems, please email me and we'll work through those.